Hey guys, I wanted to look at some achieved problems with you. It's number 11 and number 12 in section 7.6. They both go back and deal with substitution. For number 11, you're given a problem where you have something similar to the integral of x over the square root of x minus 2 with respect to x. So what's messing up this problem is that square root of x in the denominator. So the first thing I do is I go ahead and I get rid of it. I'm going to use a substitution. Let's let u equal that root of x. So if u is equal to the root of x, which we know is x to the 1/2 power, then its derivative is going to be 1/2 x to the negative 1/2 with respect to x. Now I know I have a dx in the problem, so it helps if you'll solve for dx in your derivative here. Well, I know if I get dx by itself, I would have to multiply both sides by 2. And I'd have to multiply both sides by x to the 1/2 power, otherwise the square root of x. So notice from here to here I'm just saying dx is equal to 2 on the square root of x times du. And then I can go back and say I need to get dx totally in terms of u. I already know that the square root of x is u, so 2 on the root of x becomes 2u times that du. That enables me to be ready to go back into my original integration problem. I can say if I is the original integral, then I is equal to x. We know the root of x is u, so x is going to be u squared. Then dx, I've already shown up here, is 2u du. My denominator, the whole point of this was to say that u is equal to the root of x, so my denominator becomes u minus 2. Now, instantly I see that my numerator is going to be greater degree, so I go ahead and I factor the 2 out, and then u squared times u is u cubed. Now, as soon as I see that that numerator is a greater degree than the denominator, I know I have to use long division. So over here you'll see I divided u minus 2 into the u cubed. So I said u goes into u cubed, u squared times u minus 2 gives me the u cubed minus 2u squared. We subtract that group out. Of course, the u cubes cancel, but you're left with a positive 2u squared. U goes into 2u squared, 2u times u minus 2 gives me this 2u squared minus 4u. Again, you need to remember you have to subtract that out. The 2u squareds cancel, and you're left with a positive 4u. U goes into 4u 4 times. 4 times u is 4u. 4 times negative 2 is minus 8. We subtract that out and we get a positive 8. Now, this enables me to see that this integration problem is just going to become 2 times all of this that divide evenly in one integral. So it's 2 times the integral of u squared plus 2u plus 4 with respect to u. And then I need to remember the remainder is also inside this integrand multiplied by 2. I separate that and I'll say plus 2 times the integral of the remainder 8 divided by what's still in the denominator of that term, u minus 2. Now this becomes extremely easy to integrate because I can say all of the first set, it's just the power rule. So I get u cubed over 3. This would be 2u squared over 2, or just u squared. The last term, 4u. Over here, I can see if I factor that 8 out and multiply it by the 2, I would get a 16. And then the derivative of the denominator, which would be just 1, is in the numerator. So every single time that happens, your answer is the natural log of the denominator. So that second group is just going to be 16 natural log of u minus 2 plus c. After this, all you have to do is go back and put your answer in terms of x. So in this first one, I would have, if u is the square root of x, then that's going to be the square root of x cubed times the 2/3 out in front. So I said 2/3 on the root of x cubed. The second term, the square root of x squared is just x. You're going to have a 2x. The next term, you're going to have 8 on the root of x. Then, of course, we have our plus 16. We put the root of x in for u, so plus 16 natural log of the absolute value. You need to remember the absolute value of the root of x minus 2 plus your constant of integration. Now, for number 12, it's also a substitution problem. It's going to look like this. So with this problem, I'm given something like the integral of x squared over the square root of x plus 8 with respect to x. The difference in the last problem and this problem is that the entire denominator is in the square root. So you have no option for your u substitution. You're just going to have to let u equal what's inside of that group. And then when I do that, I know du is dx. And then I can say, well, if u is x plus 8, then x is going to be u minus 8. And then I can go back into my problem and evaluate. So x squared is u minus 8 quantity squared. I know dx is simply du. That denominator now is going to be u to the 1/2. This makes it very nice, because then all I'm going to need to do, guys, is to expand out that numerator. U minus 8 times u minus 8 is going to be u squared minus 16u plus 64. Then I can say that entire numerator divided by u to the 1/2 power is going to become u to the 3/2 minus 16u to the 1/2 plus 64u to the negative 1/2. Please remember, you have to do the algebra simplification before you can do the calculus. Now that we've done the algebra, you can do the calculus. The power rule says to add 1 to each of these exponents and divide by that new exponent. So we get 2/5 u to the 5/2. The next one, this is going to go to the u to the 3/2 power. So I said 16 times 2/3 is going to be 32/3 u to the 3/2. My next term, u would go to the positive 1/2 power. So we're dividing by 1/2, same thing as multiplying by 2. And I can say that's where the 128 u to the 1/2 came from. And then plus my constant integration. Last step here, all we need to do is put these terms of u back in terms of x. We know u was x plus 8. So this is going to be the square root of x plus 8 to the 5th in the numerator along with the 2. This next one is going to be the square root of x plus 8 quantity cubed in the numerator along with the 32. And the last one is just 128 on the square root of x plus 8 plus your constant integration. That should help you out through problems 11 and 12 and 7-6. Please let me know if you have any other questions. I'll be glad to help with any of them.